A very good morning, students. So in our previous video we have already covered some of the topics of class 9th first science chapter, that is matter in our surrounding. We have learned what is matter, then we have learned the characteristics of matter, diffusion and its application in that video. And in this video we will be going to cover the remaining further topics. So we will be going to study different states of matter and how we can convert the states of matter, like how they can be converted into different states. Then we will be studying the effect of temperature and pressure on the matter, and some basic terms will come under this, that will also we will study. And then at last we will be studying some of the important basic physical quantities which we are going to use and their SI units. So let's start our first topic, that is states of matter. So as I already told you that anything which occupies space and have some mass, they are called matter. Okay, so means everything can be considered as matter. So basically if we talk about the forms in which they exist, there are basic three forms in which the matter exists, like solid, liquids and gas. Okay, these are the basic forms of matter in which anything occurs. Okay, if I talk about fan, it is basically considered as solid. If we talk about water, which is also a matter, it is found in the form of liquid. And if I talk about air, it is in the form of gas. So basically three forms of matter are there: solids, liquids and gas. Now how we can differentiate these three forms of matter? So we will be now studying the certain characteristics of these three forms of matter. Okay, so one by one we will be studying it. First thing, if we talk about definite shape, then we can say that solids, they have definite shape, means they have fixed shape. And if we talk about liquids, their shape can be changed according to the container in which we are filling. And the same if we talk about gas, their shape also can be changed, means they don't have definite shape. Only solids have definite shape. Liquid and gases, they do not have definite shape. Second thing, if we talk about definite volume, then we will found that solid, they have a definite volume, means whatever the volume they are having, they have fixed volume. And if we talk about liquids, they are also having the definite volume, though their shape can be changed but their volume not changes. Okay, and if we talk about gases, then they are not having any definite volume, means whatever, if we are taking big size container, then their volume will be according to that. And if we are taking a low very small container, then their volume can be changed according to that container. Okay, so now here we have understood two things, that solids have definite shape, they have definite volume. Liquids, they have definite volume but no definite shape. And gases, they are not having any definite volume nor they are having definite shape. Third thing, if we talk about compressibility. Compressibility means if we are applying pressure, then by applying pressure we can change the shape of anything, okay, any matter. So now if we talk about solids, so the compressibility is, we can say it is very less or it is not there. Okay, if you take a stone and if you try to compress it, can you be able to compress it? We can take a simple example to understand this one. Okay, you know the syringe. Okay, take an empty syringe and what we have to do, fill some stone into it. Okay, and the piston is there on the top. So if you will press the piston, you will find that you are not able to move it. This is because solids, they are incompressible. If we are taking liquid, then again do same thing. Okay, fill in that injection, in that syringe, the liquid, and try to push the piston. You will be not be able to compress it, because the compressibility of liquid is very less. And if we are trying the same thing with gases, then we will find that gases have highest compressibility. Gases means if you are not filling anything in the syringe, then also air is there inside the syringe. Okay, now if you will press the piston will move. This means that the air inside it has little bit compressibility. Before moving the piston, what we have to do, we have to cover the front portion. Okay, then only, otherwise what will happen, air will pass. So in this way we can say that solids, they have no compressibility, liquids or less, very less, negligible, and gases, they have little bit compressibility. Now this also we have understood this factor, compressibility. Now if we talk about kinetic energy, basically this is the energy which is due to the motion. We know that the particles of matter, they are constantly moving, so they are moving because they have kinetic energy. So if we talk about solid, we will say that here the solid, the particles are very tightly packed, force of attraction is very high. So how it is possible to move the particles which are held very tightly? Okay, when you will beat a bench, what will happen? Vibration will take place. Okay, so in the case of solids, what happens? The particles cannot move from their place. Instead of that, they are vibrating. Okay, in the case of solids, they are not freely moving, but they vibrate. If we take liquid, they are little bit moving. Okay, particles of liquid matter, they are little bit moving. And if we talk about gases, the particles of gases, they move very freely. Now if we talk about density, density here is basically mass per volume of any substance is called density. So if we talk about density of solid, it is very high, density of liquid is less, and density of gas is very least. Okay, so now let us talk about the conversion of matter, means from one form to another form. Or we can say that by differentiating the temperature, or by providing different temperature to different forms of matter, the forms of matter can be converted from one state to other state. How this is possible? Okay, you have noticed that ice kept in open, means basically it is if we are taking some ice from fridge or refrigerator, and if we are putting it out, what happens? It start melting. This again because it gains heat, right, which is already present in our atmosphere. Then if we start boiling a liquid, then it starts converted into gas. So this happens by providing different temperature, we can change the state of matter. The reason behind the change of conversion of matter is that whenever we provide heat energy to the matter, what happens? The particles, they gain energy, and they will have now kinetic energy. Kinetic energy basically required for moving. Okay, now the particles will start moving. Now it is solid, and we know that in solid the particles cannot move. Okay, now since they are gaining the kinetic energy, now they can move a little bit. So now since the force of attraction between the particles is now overcome due to that kinetic energy, so now that solid can be converted into liquid easily. The same thing happens with liquid. The particles of liquid will gain the kinetic energy, more the kinetic energy. Okay, then they will be converted into gas. Now what happens if you want to convert a gas into liquid? What we will do? We will be providing it, we will be keeping it into a very less temperature. There are certain basic terms you should know. The first is boiling point. Now here if we define boiling point, basically the point at which any liquid starts boiling at atmospheric pressure. Okay, that it is called its boiling point. If we talk about melting point, basically the point at which any solid starts melting at atmospheric pressure is called melting point. Then latent heat of fusion. Basically fusion, whenever a solid changes into liquid, the process is called fusion. So latent heat of fusion is basically the amount of heat energy required to convert 1 kg of solid into liquid at its melting point is called latent heat of fusion. मतलब कितना हीट एनर्जी रिक्वायर्ड होगी 1 kg सॉलिड को कन्वर्ट करने में, किसमें? लिक्विड में, उसके मेल्टिंग पॉइंट पे हम उसे क्या बोलेंगे? लेटेंट हीट ऑफ फ्यूजन. Then latent heat of vaporization. Here it means vaporization means a liquid converting into vapor. So how much heat is required, the amount of heat required to convert 1 kg of liquid into gas at its boiling point is called latent heat of वेपराइजेशन मीन्स 1 लीटर ऑफ लिक्विड को कन्वर्ट करने में, वेपर में कन्वर्ट करने में कितनी हीट एनर्जी रिक्वायर होगी, उसे हम क्या बोलेंगे, लेटेंट हीट ऑफ वेपराइजेशन. हैव यू अंडरस्टूड दिस 4 टॉपिक्स? मेल्टिंग पॉइंट, बॉइलिंग पॉइंट, latent heat of fusion and latent heat of vaporization. Now the effect of temperature on matter we have already seen. Now we will see the effect of pressure on matter. Pressure, what happens whenever we apply the pressure on any form of matter? If we see the structure of solid very carefully, we will find that the particles of solids, they are very tightly packed. There is little bit gap present between liquid, and the particles of gas is they are very far from each other. So if we will provide, suppose you have taken a liquid, okay, we know that little bit gap is present between liquid, particles of liquid, and due to by any experiment, if we are able to remove that gap, means if we are providing the pressure, what will happen? The particles of liquid, they will come together. Now since they are coming together, it means that now they are not liquid, they can be now considered as solid because it is having the characteristic of solid. Okay, again if we are taking a gas and again we are applying the pressure to bring the particles which are very far to little bit closer, what will happen? Now it will be not considered as gas, it is converted into liquid. We know that the LPG, liquefied petroleum gas, which is filled in our cylinders which we are using at homes for cooking, here basically the gas is there. Okay, that's why we are calling it liquefied petroleum gas. This gas, whenever we are filling in the cylinder, we are applying the pressure. Due to that pressure, the gas changes into liquid and it gets liquefied. That's why we are calling it liquefied petroleum gas. Again, when it comes in the atmospheric pressure, what happens? The pressure which we have applied inside that gas cylinder, it will be overcome and then again it will be converted into gas. Whenever the this liquefied petroleum gas, it comes out of the cylinder, then again it gets converted into gas. I hope you have understood these things. Evaporation. Now here, what is evaporation? Basically the process of conversion of liquid, okay, into gas or into vapor, that we can say that evaporation. So here this evaporation technique is used to means finding out the salt from seawater. Okay, evaporation happens here due to that high sunlight energy, the liquid gets converted into gases and the remaining salt we are collecting it later on. So here evaporation, if we talk evaporation, it is very important phenomena also. Okay, whenever any evaporation takes place, what happens? There is a cooling effect also. Cooling effect, how we can say that? For example, in a very hot humid day, you are sitting outside, so you start sweating. Okay, so you start sweating and then suddenly you feels very cool. Okay, what happens? Whenever air blows, you feel very cool. This because of the reason of evaporation. The water which is present on your body, means the sweat which is present on your body in the contact of sunlight, in contact of wind, it starts converting into gas. So means liquid is converting into gas, means evaporation is taking place. So due to this reason, and whenever evaporation takes place, cooling effect is also there. That's why you feel very cool. And this is the reason why we are keeping the water in pot, mud pot. Okay, so it is very earthen pot, it is very cool. during summer days also. This is because of the same reason. Means the earthen pot, they have small pores, minute pores, not big pores, otherwise water will come out. So very minute pores are present on earthen pot, and if we are filling it with water and if we are keeping it somewhere, so what happens here, evaporation is taking place. How? The through that small pores the water is seeping out. As soon as the water comes out, it comes in contact with heat, and the state here, the state of liquid is changed into gas. Since here evaporation is taking place, so again cooling effect will be there. Due to that cooling effect, the water in an earthen pots is becoming very cool and chilled. Understood now where we are applying this evaporation process, and it is very important process also. If we talk about boiling, basically it is a boiling is a bulk phenomena. Bulk means the every particle of liquid, they will gain kinetic energy, then only they can be converted or they can be boiled. Okay, they can be converted into different state. But for evaporation, if we talk, it is a surface phenomena. Means the particles which are present on the surface, they can gain the energy and they can convert the state of matter. They can be easily converted from liquid into gas. So understood here, boiling is a bulk phenomena and evaporation is a surface phenomena. Now there are certain factors which affect evaporation also, like surface area. If we increase the surface area, evaporation also increases. How? Suppose you have taken water in a glass and you have taken water in a plate. Okay, and you kept outside both the water in sunlight. What if you will observe it whole day, if you will keep it, and afterward if you will observe it during a hot day, you will find that the water which you have kept in a plate, the quantity is little bit less, and which you have kept in a glass, it's having the same quantity maybe, or little bit less is there. This is because of the reason same. If you are keeping anything in a wide or in a bigger surface area, so more particle will get the chance to convert into one state of matter into another state of matter. And again, if the surface area is less, so less particle will get the chance to convert it from one state into another. Understood now? So increasing surface area can increases the process of evaporation. Now again, we can take here example, whenever you are spreading your clothes outside, okay, for drying them up. So what happens, we are not keeping the clothes simply on one another. If we will do the same, what will happen, less the surface area, less will be the evaporation. It will take more time to get dried. Okay, and if you are spreading it very nicely, then within 1 hour or within 1.5 hours, they will get dried up very easily. Okay, because here the surface areas we have increased, the more particle will get chance to convert from one state of matter into another. Second is that if we increase the temperature, same again, if we will provide temperature, the particles, they will get kinetic energy, they can easily convert from one state into another state. Okay, humidity means the amount of water vapor in air. So here what happens, in evaporation, the liquid, they get converted into vapor. If suppose already the water vapors are present in atmosphere, so means the particles of air, they are having already the water vapors in there. So this new particle, they will not get the chance to go and settle in that place. Okay, so during an humid day also, the evaporation is very less. So more the humidity, less will be the evaporation. If we will say about wind speed, more the wind speed, more will be the evaporation. How? If the wind speed, what it does, the water vapor which are present in air, it can take it away with that wind, and the remaining area there, the evaporation can take very easily. Understood now what all are the factors which affect evaporation? First is surface area. More the surface area, more will be the evaporation. Second, humidity. More the humidity, less will be the evaporation. Third is our wind speed. More the wind speed, more will be the evaporation. And fourth is our temperature. More the temperature, more will be the evaporation. Understood now all these things? Now let us discuss some of the basic physical quantities which we are going to use in this chapter. Okay, temperature, its unit is Kelvin and its symbol is capital K. Length, its unit is meter and its symbol is small m. Then mass, its unit is kilogram and its symbol is kg. Then weight, its unit is Newton and its symbol is capital N. Volume, its unit is cubic meter and its symbol is meter cube. Density, its unit is kilogram per cubic meter and its symbol is kg per meter cube. And pressure, its unit is Pascal and its symbol is P. So I have explained all the topics which we should cover in our first chapter. So students, what you have to do? You have to listen the video very carefully and note it down, or you can make your notes by listening it very carefully. Okay, and try to understand it, and I hope you all have understood also. Thank you.